This is a brief lecture on Chapter 5 of Fundamentals of Financial Management, focusing on the concepts of time value of money. This brief lecture will look at the following concepts: future value, present value, also finding interest or rate, and number of periods or time. We'll also look at the concept of annuities, rates of return, and amortization. With time value of money, it is important to understand that we're looking at cash flows over multiple time periods. Now, those time periods could be days, months, years, but whatever the case may be, we want a way to illustrate that. And one way to do so is timelines. You'll see timelines in this chapter and in other chapters to help illustrate this. So we see in this, we have a cash flow subset 0 at the very left-hand side. That represents the cash flow at year 0 or today. And then we see cash flow 1, 2, 3 representing the cash flows in those future periods. I represents the interest rate, and so I or R can be used for that notation. And then T or N can represent time, and so we see 1 time period, 2 time periods, 3 time periods. To illustrate this a little bit further, we see that sometimes we'll have a single amount which occurs in more than 1 time period away. So we see a single amount in 2 years. We also see ordinary annuities where there is cash flow at the end of the term. Those cash flows are the same amount and on the same timing. We also have our uneven cash flows, and so we can see how we can calculate those. So let's look at those first values, that single sum, looking at future value and present value. So we see here a single amount in the 2-year time frame. So in the first example here, we see that there is $100 that will be received in 2 years. What would it be today? So the calculation for that, we would be looking at the present value. It equals the future value divided by this time value factor. And the time value factor is calculated by taking 1 plus the interest rate and taking it to the time exponent. So we see that here. If we do the calculation, we get the $90.70. We also see that we can do this in Excel. There's multiple ways in which we can calculate this, either just doing the math longhand, using Excel, or even using the financial calculator, which is mentioned in the textbook. However, for the working professional, especially for the graduate student, Excel is the application you should become more familiar with because it is the application you most commonly see in business. And so being able to be familiar with those formulas is very important. So that's why it's illustrated here. Now, instead of looking at present value, let's talk about future value. So future value, what if I had that $100 today? What would it be in 2 years if I'm earning 5% and that 5% is compounding? That's one of the very important things to understand about this chapter, is that when we're talking about time value of money, compounding is an essential component. So understanding the power of compounding, we'll see that illustrated in some future examples as well. So this is the fundamental component. One thing that we should know is that these equations, or this one equation, just configured in a couple different ways, has 4 variables. We have a future value, we have a present value, we have I, which represents rate, interest rate, and N, which represents number of periods or time. So what happens if we have present value and future value, but we're looking for rate or time? Well, there are formulas for that. There are mathematical equations that could be used, but in the rate equation is simpler than the time equation. The time equation requires some natural logs to be used. But what we see here in the first example in calculating rate, we have a present value of $80. We have a future value of 100. We know that we have 2 time periods. We just don't know the rate. And so we see if we put that calculation in there, we see that for $80 to grow to $100 in 2 years, it should grow at 11.8%. Now, in the next example, we see calculating time. in or in per, we see that if we're taking our $50 and we want that money to double to 100 and we have a 10% rate of return, what we see is it takes 7.27 years. And so that's the amount of time it takes for the money to double, assuming that that compounding period. And so we see here N is put there, so we don't know the number of years between where we're trying to calculate and 0, and so it's a timeline that would have over 7 years built into it. So that is for a single sum. The next component is talking about annuity. Annuity is very important, especially when you get to the valuation of bonds, which you'll see in chapter 4, or in week 4. So when we're talking about annuity, there's two types. There's the ordinary annuity. This is the one that we talk about the most in finance because the payment happens at the end of the period. However, there is what we call the annuity due, and that's when the payment happens at the beginning of the period. And so because of that, and because you're getting your money faster, because the payments, either you're receiving payments faster or you're paying payments sooner, the value becomes higher, and so you'll see that in some homework problems. So let's look at the stream of payments. So the example here, $100 each year for 10 years at 5% interest. Now, it's worth noting that if we were at 0% interest and we were receiving $100 every year for 10 years, that would be $1,000. However, once we start putting in interest in here, it changes the value. And so we see here calculating the present value of the annuity. You see the mathematical formula there. However, we see the Excel formula next. We're using present value, but then we see here at the end there is an additional field called type. If type is left blank or is a 0, it would be an ordinary annuity. If we were to put a 1 where type belongs, that would be a annuity due. And so we see here that the present value of that $100 received every year in the future for 10 years is only worth $772.17. That is the mathematical result of that compounding factor, or in the case of present value, the discounting factor. In the future value of an ordinary annuity, we see here same rate, same time period, same payment, but we see that as it is growing by 5% each year for the 10 years, it ends up, instead of $1,000, $1,257.79. And so this is the important concepts that really undergird a lot of what you see for the remainder of the textbook. So this is finding time value for an annuity. The last is, what if we have uneven cash flows? Well, in the case of uneven cash flows, what we would have to do is discount or calculate the present value of each cash flow individually and then sum them up. And so we see here, if we were to take $100, discount it by that 4% to get a present value, we see that value there. The $300 over 2 years, $300 in 3 years, and then the negative $50 in 4 years, we come up with a value that represents the present value. Now, the nominal value, if we took the 100 plus the 300 plus the 300 plus the negative 50, we would have $650. However, using the present value formula, we have $597.48. So this is time value. Time value is an essential concept which undergirds really all that we do quantitatively within finance, especially corporate finance. And so this is a concept that you need to master. This is also pertinent to personal finance and any other number of fields as well. So let's talk about interest rates. We talk about interest rates, and we'll talk more about that in future chapters, but we need to be aware of what type of rate we're talking about. We can talk about a nominal rate, which is really what the rates have been up to this point. Or we can talk about an effective rate. An effective rate helps us understand the power of compounding when compounding happens more than once a year. And so we see here there's an effective rate calculation. We see those values here, and we see that 4%, if it's actually compounding semi-annually, actually has a little bit higher rate. Not significantly higher. We're going from 4% to 4.04%, but if we're talking about large sums of money, it makes a difference. This effective rate, especially with this semi-annual compounding, becomes important for bond valuation. So please make a note of that for future chapters. Just to illustrate the importance of this effective rate, we see that as the compounding periods become more frequent, going from an annual rate to a semi-annual down to daily, and a lot of banks do compound daily, we see that there is those fractions of a percent more. And so, again, with large sums of money, every component within the interest rate makes a difference. The last concept from this chapter is loan amortization. Loan amortization is very relevant for personal finance. For those of you who have mortgage loans, auto loans, anything along those lines, they are usually calculated with an amortization table. And so trying to identify what your payment is and what the mix of principal and interest is in each of those payments, so that once you get to the end of the loan, you have paid back all of the principal and the interest. And so we see here, we have an example of a $1,000 loan at a 4% annual rate with 3 equal payments. Now you'll see the illustration here is actually the financial calculator buttons, which you'll see in the textbook. And so we see N as that 3, I for the number of years, IY is that 4%. Present value, a negative $1,000. What you will discover in calculating this is that you have to have a cash outflow, so cash out of your pocket negative, cash back into your pocket positive, or vice versa. So there is a negative cash flow and a positive cash flow, and that's all that denotes. So usually with your answers within the homework, you would just take the absolute value. What we see here is that payment would calculate to $360.35. Now, it's worth noting, if we took $1,000 and divided by 3, it would be $333.33 repeating. But once we enter in interest, it changes that value. So let's look at the amortization table. So we see here, we start with that $1,000. The payment, we're just rounding those payments for simplicity. We get $360. We discover that 4% of that $1,000 is 40. So if we're having to pay 40% interest, the balance, 320, is the principal. And so we see the ending balance. So then in year 2, we start with that new beginning balance, the ending balance from the previous year, that's 680. We have the same payment, but now it's 4% of the $680, which is why we now have interest of $27 instead of 40. We do that same calculation, subtract the 27 from the 360. We get the new principal balance, and so now we see what the new payment would be. So what this does is that as a loan continues to be paid, the amount of principal goes up, the amount of interest goes down until it's all paid. So this is a brief lecture on Chapter 5.